All right, mathletes. So what we're going to look at is rational equations, and rational equations are pretty deep. All right, so just to give you a heads up, what we're going to be looking at are rational equations that you would see in a level 1 algebra class. Maybe you'll use this to reference in algebra 2 as a reminder, but these aren't going to get too complicated. This is like an introductory, right? I'm going to make another video that's going to have like a level 2 and 3 rational equations that are a little bit more complicated, because what you're going to see is that these rational equations, the more complex they are, they're going to turn into either linear or quadratic type problems, and they're going to get pretty complicated and fun. All right, so right now we're just going to look at the overall arching idea, right? How do we go about solving these? And this today is going to help you on any type of problem, right? Except we're not going to get too advanced here. All right, just to let you know. All right, mathletes, so check it out. How do I know I have a rational equation? All right, so remember, rational just means that we have a fraction somewhere, right? So what you know is you're going to have one or more fractions in your equation, okay? So one or more fractional expressions here. So here we have a couple fractions in our equation. So that's how you know that this is a rational equation. All right, so that's huge. That's very important. So what's the process look like? Well, the first thing I like doing, there's so many different ways of doing this, is I like to identify what is that LCD, that least common denominator. And in this case, our LCD is 4, right? This guy, the denominator is really a 1. So our LCD, our least common denominator here, is 4. So let me identify that. So it's 4. So what are we going to do with that 4? So what we do with that 4 is we multiply it times every single term, all right? That every single little expression here. So everything's going to get multiplied by 4. So let's copy this down again. All right, I'm going to leave myself some space because I'm going to multiply each one of these by 4. So you get a 4, and you get a 4, and you get a 4. So everything is going to get multiplied by 4. And you could write it like this, or if some of you prefer to write it over 1, that's absolutely fine in front of your fractions. If that helps you, then you do it. So again, you want to do this the way that helps you out the most, right? So here, the reason some people like to write as a fraction is so that they could see I could divide 4 divided by 2, right? We could cancel these two. So sometimes that's why it helps to write it over 1. So again, whatever helps you out, that's the way I want you to do it, all right? So 4 divided by 2, that's going to leave us with 2. And then these 4's over here are going to cancel. So what are we left with? Well, here we're left with the first piece, we're left with 2y. Here we're left with y, and here we're going to be left with 24. So let's go ahead and rewrite this. 2y plus y equals 24. And what's awesome about this is once you, regardless of how complex our rational equations is, once you multiply by the LCD, then we go back to all our other tools that we know. So check this out. This right here is a linear equation. And I say it's linear because look at the biggest degree, or look at the degree of this equation here, right? So on this side, if I just look at my left-hand side, this polynomial has the degree 1, right? So the biggest exponent that you see is 1. So you got to be careful there. Make sure you identify that. And so this is what you're hoping for, right? Because when it's a 1, then it's really easy to solve. I could add these two. So 2y plus 1y, that just gives me 3y, right? So this, now I'm going back to my regular linear equations, which are very easy to solve. Then I divide both sides by 2, by 3, divide by 3, divide by 3. So we're left with y equals 8, right? And now you could plug it back in just to make sure you didn't make a mistake. And so 8 divided by 2 is 4. 8 divided by 4 is 2. So 4 plus 2, 6. Absolutely. So we check our work and we're right on. All right. So there's the example 1. And notice with this example, both of my denominators here were numbers. So what happens when they're not numbers? Well, follow me. All right. So look at this example. Our denominator, it has a variable. So the most important step here is to make sure you smash that like button and subscribe, all right, so that you don't get confused by these types of problems. All right, so we need your help, mathletes. Make sure you like this video, subscribe, so that YouTube could let everybody know what Dr. Math is doing for you guys. All right, so usually when I have a variable, that's where people start to get nervous, right? They're like, wait, what do I do now? Right? The rules don't change, right? And that's what's awesome about math. The rules never change. Sometimes situations make us nervous and forget things, but the rules never change. So our LCD, first what I want you to do is look at your numbers, right? The 3 and the 6. The LCD of 3 and 6, well, it's just 6, right? And now all you're going to do is grab that x, right, that variable, and attach it here, right? So boom, that's going to be your little shortcut. If this were a y, you'd put the y there. If this were x plus 1, you put parentheses x plus 1, all right? So there's our LCD. And here's what I want you to understand. Let's go ahead and multiply everything by the LCD, like we know. But look what happens. This is how you're going to know if you actually did find the LCD. Watch. Let's go ahead and write this. So I'm going to multiply everything by x plus 1. And this time I'm not going to write it over 1. You can, right? And if you need to, then do so. But I'm not going to do so, just so for those other people who don't want to write the 1 on the bottom, I just want to show them what this looks like. All right. So I could put the little dot there, right, to mean the multiplication. So we multiply everything by 6x. So the first step, exactly the same. We find the LCD and we multiply every single thing by that LCD. All right, now let's cancel. So look what happens when I cancel. So this x will cancel with this x. 6 divided by 3 is 2. And then 6 divided by 6, those will cancel. So notice your denominators are completely gone. And that's what we really want. We want those denominators to be gone. Because now when I rewrite this, I'm not going to have any fractions, which is awesome. That's going to allow a lot of you guys to sleep at night, right? So whatever your LCD is, when you multiply it, remember, it better completely eliminate those denominators. All right, so I'll write that down if you think you'll forget. So let me rewrite, let me copy down what's left. All right, so I'm just copying down whatever didn't cancel out. So again, here we were left with 6 times x plus 1. Here we're left with 2x, all right, times 1, which is 2x. And then here we're left with the 5. So again, I just copied that again. And here I want to get rid of my parentheses, right? We want to see what kind of equation we have. So let's distribute that 6. Make sure you distribute it to both. All right. So now it's easy to see that we have, again, a linear equation, which is great news because now I could combine my like terms. 6x plus 2x. That gives me 8x plus 6 equals 5. Go ahead and subtract 6 from both sides. So we're left with 8x, right? Those cancel, equals negative 1. And we have x equals negative 1/8. All right. So once again, just because our denominator had a variable, the rules don't change. So first find those numbers in our denominator, find the LCD of the 3 and the 6, which was 6, and then tag on that variable. It's that easy, folks. All right. So let's look at what's in store for you. All right. So before we continue, we have problems 1 and 2 right here for you to solve. All right, so go ahead and solve them and then comment down below with your answers. Number 1, what did you get? And number 2, what did you get? All right, so let's move on to our next example. But again, we want you to try these because don't just sit down and say, okay, I get it. You have to get your hands dirty. You have to make mistakes, right? That's the only way that you learn math. That's the only way you learn anything, right? You got to get your hands dirty. So make sure you do that, mathletes. All right. So next example, notice we have a -2, and again, this is one of those where people see it and right away they freeze and they don't do anything. You got to do something, mathletes. You can't just freeze like a deer in the headlights, right? So we got to make a move, all right? I don't want you ending up like this guy. All right, so first things first, rules don't change. Our LCD, well, I only have one denominator. Well, I have 2, but they're exactly the same. So my LCD is a minus 2. So what are we going to do? We're going to multiply everything by a minus 2. A minus 2, you get an a minus 2, you get an a minus 2. So everybody gets an a minus 2. So this one was 3a over a minus 2. I'm just copying down everything here. All right, so everything got multiplied by a minus 2. All right, so let's go ahead and distribute. I'm going to multiply by 1. That's not going to change anything. Notice here, the a minus 2 factors are going to cancel. So this is going to cancel with this. Nice. This a minus 2 cancels with this a minus 2. So see how easy this problem really is once you get the big idea. So you're left with a minus 2 plus 3a, and that equals 6. Now it's easy to see that we have a linear equation here, and which are the ones that we want. These are the ones that are really easy to solve. Once we get into something like a squared, that's where it gets a little bit more complicated, because now you have a quadratic, right? If you haven't seen one of those, then don't worry about it. We're gonna teach you later, right? So if you have seen quadratics, then you know you could either you set one side equal to 0, then you factor it. If you can't factor it, use a quadratic formula, right? We have tools. So here, let's combine our like terms. 1a plus 3a, that gives us 4a. Nothing happened to that minus 2, so I'm going to drop it like it's hot. Boom. All right, so all I did is I combined my like terms. So 1a plus 3a, that's what gave us that 4a. All right, so no magic there. Let's solve for a. So we're going to add 2 to both sides. All right, you get a 2 and you get a 2. So you're left with 4a equals 8. And now let's divide both sides by 4. Divide by 4, divide by 4, because we're solving for a. So a equals 2. And this is why it's so important for us to check our work, because a lot of people will be like, all right, we're done. But look what happens when I plug in a equals 2 back into my equation. On the denominator, in the denominator here, I'm going to get 2 minus 2, which is 0. Can you divide by 0? Right? If you divide by 0 on your calculator, you're going to get an error. If you have the Dollar Tree calculator, it just might blow up, right? Too much power. So it can't happen. So when I plug in a equals 2, when I plug it in, right, I cannot divide by 0. It leads to an error. What we say later on as you get into this is that a is not in the domain. If you haven't learned that word yet, don't worry about it. So a is a restricted value, meaning a equals 2. So 2 is a restricted value, meaning a can never equal 2, not even on Sunday. So what we do is we cross it out and we say that there is no solution. So that's why it's so important that you always go back and check your work, because sometimes, right, you might get something lying to you. All right, so check your work. Follow me to the next example. All right, mathletes, so our final example, number 3, is in your hands. So before we start, look at the denominator, right? Should look very familiar based on the last example we did. So we want you to use that example, look at your notes, and try this problem. Comment down below what you get for number 3. All right, mathletes, so again, as you're going through this work, it's going to take time, so be patient with yourself. Be ready to make mistakes, right? That's part of the game. That's the only way you grow. All right, so hopefully this was helpful. Hopefully you like this, and make sure you help us out. Subscribe, tell a friend or 10,000 about the good work we're doing here in Dr. Math Studios. Have a great day. Peace.